So, hello everyone, my name is Akshay and welcome to this GFG Pure streak of day 86. तो देखते हैं आज का क्वेश्चन क्या है यार and before moving forward, if you're new to this channel, please like, share and subscribe and let's move ahead. So, आज के क्वेश्चन का नाम है finally it's a medium category of question after 3 days of hard question. So, I hope you were able to maintain your streak and was able to understand the ins and out of the previous 3 days question. So let's see to it. So the question name is next greater element. Given an array of size n having distinct elements, the task is to find the next greater element for each element of the array in order of their appearance in the array. Okay. So next greater element nothing but is the nearest element on the right, which is greater than the current element. So if there does not exist next greater to the current element, then you have to give the current element as -1. For example, there's a test case here for 1, 3, 2, and 4. So let's get started with the paint and try to see that how the input and output are coming. Okay, so I can see here that for 1, 3, 2, and 4, I can see in the right of this index, which is the immediate greater element is 3, right? So I can say 3 here for this index. Now, when I'm at this pointer, what's the next greater element in the right hand side? So among 2 and 4, it's 4, right? Now, when I'm at this index, I can see that only number which is greater than 2 and in the immediate is 4. Similarly, for 4, there is no elements in the right to compare it with, so do the -1. Okay, so the next test case is 868013. So I can see that 6, if I move ahead to find greater than 6, then I encounter 8, so I will write 8. And if I move ahead from this point out to find greater than equals to 8, I found none, so I will give as a -1. Similarly for 0, I found 1 just close to it. I will say 1. For 1, I found 3. And for 3, there is no elements in the right hand side, so I will just say -1. So what should be our approaches? So a naive approach here or brute force, you can say, coming to my mind is that we can run a nested for loop that for I equals to 0 to I less than n, I plus plus, right? And the next loop will from j equals to I plus 1, j less than n. This is what we were doing. When we're at this pointer at first element at 6, I just traverse for the rest of the part finding if there's an element which is greater than this ith pointer. And as soon as I found if array of j is greater than array of I, as soon as I found what I do, that I update the element, that array of I is updated to array of j, the answer we found, and then break it from here, right? And if you are not getting any element, then you have to fill it with -1. So let's do some pre-processing. After making an answer array, let's fill it by answer arrays dot fill answer comma -1. So if this case does not hit for any of the cases, I like for 8, if I traverse in the right 0 1 3, I do not found anything, right? So this for loop will not update this thing because I initially handle it using the arrays dot fill that goes to -1. So what is the time complexity of this approach? So method 1, we are doing two nested loops, so that is n square. So let's see what's the constraint given here. Constraint given is 10 power 6, right? So it is given 10 power 6. So if you do 10 power 6 whole square, that gives 10 power 12, right? Which is basically greater than 10 power 8. So if you are able to code this approach, this will give TLE. How is this 10 power 8 logic holds true? I have made this video on this. It must be flashing up here now. You can see that. So let's code it, but still we'll code the solution. We have this thing going from, we have to understand the multiple approaches in order to develop our aptitude skills. So let's code it. So let's make an answer array. I'll make this one as long. The long answer is equals to new long of size n, right? And I will say arrays dot fill answer comma -1. And let's make two for loop for I equals to 0 to I less than n, I plus plus. Let's make another for loop for int j equals to I plus 1 to j less than n, j plus plus. I just have to see if the element in the right hand side I'm searching, that is array of j, is greater than the element for which I am searching, that is array of I. If this holds true, then we just have to update our array of I with array of j, and we break it from here because we just want the immediate closest greater element. We do not have to bother for the rest of the elements which is greater. So at last, we just have to return answer. If I hit the compile button, it will surely get our output will be getting matched. Okay, so there's some problem. What's that problem? So what I did, I just updated my current array, right? So I don't have to do that. What I have to do is to update in the answer array, right? So as you can see, the output matches, and if I hit the submit button, we'll get the TLE. Let's verify that. So 137 cases passes, and for rest of the cases, it goes beyond 10 per 8, and we have the TLE here. So what we can think for the next approach? What can we do? So if you are aware of, you may have studied data structures for stacks, then this is a very standard problem for next or previous greater element, right? So what's the intuition behind here is that instead of traversing for each and every element, we use stack for traversal, use stack, and what we do, so let me write it for you, and traverse from backside. Why backside? Because we want from this point, I want to search the nearest which is greater than, right? From backside, and we have to maintain the greater order, maintain the stack for greater element. So this is the logic behind it. So let me do a dry run for you, so you can get a clear understanding of it. So the initially the elements were 1, 2, 3, and 4, right? So I have to start from this point. So for this point, I know the answer will be -1. So I will just place -1, and I will push it in the stack, the last element, right? Now the next element come, that is 3, right? What I have to do, I have to compare if this the current ARRI and the top element, that is 4, right? So what if array of I is greater than, if array of I is greater than, let me write it for you, the logic. If array of I is greater than top, right, then we do the pop operation. So let's see that why are we doing this pop operation and how it is overcoming our problem. So in this case, it is not it array of I is not greater than, right? So what we have to do, we know for this 3 the 4 is answer, right? That is, and the 4 is what, the current element that is residing in this st.p. So before pushing this 3 into array of into our answer array, I will, let's say, make a result variable, right? And I will store here st.peak, right? And I will add it in my answer of, let's say, it was idx. So let's say we are maintaining one idx variable. So I will say that answer of idx minus minus is equals to result, correct, right? Okay, so what I can do now, I can just push the current element. Now I can push 3. So what the array will look like, the stack will look like 4 comma 3. And now the array of I, the current element which we are iterating, is this 2, right? So it is 2, and the top element is, as you can see, is 3. Now the array of I is 2 is greater than equals to 3, and you can see for 2, 3 is the answer, right? 3 is the array of I is 2, right? And it is the top is here. So what you can see here, so you can see that array of I2 is still not greater than the top element, right? So we'll just make a result variable again, and we will store st.peak here. That gives us 2 answer, and we'll update here in our answer array. We'll update with the result thing, and what's the peak? It's 3, right? So we'll update it 3, and then we will push 2, right? So fine. Now the stack is looking like 4, 3, and 2. Now the current element, what's the current element now? Array of I is actually equals to 1, right? And top is 2. Again, 1 is not greater than equals to 2, right? So again, the result will be equals to top, that is equals to 1. Store it in the answer here, 1. Actually, result of top is equals to 2, and store it in the answer here, that is 2. And then push I, so push 1. So finally the stack is looking like 4, 3, 2, and 1, right? So since our all elements have ended, and we have got this answer as 2, 3, 4, and -1, that is true for this 1, 2, 3, and 4. And as you can see, the intuition that worked to maintain the greater elements, as you can see that each and every step, the order was maintained. that is from greater to lower. And that's the intuition, that why are we considering the lower elements when we have to find the greater one, right? So I think the array given was 1 3 2 4, and I dry run it for 1 2 3 4. So let's dry run it again. So let's run it for 1 3 2 and 4. So okay, so initially it will have 4, and the array, it will come as 2, right? The If I just write it, array of I, and top will come as 4. So again, this does not hold true, and we'll just store the result as the top element, that is equals to 4. I'll just maintain one answer array here, answer array, and I will just push here this thing. So it will be 4, and I will push the current element, that is 2, right? So now the next stack will look like, our stack will have the element 4 and 2, right? Now the array of I is pointing to which one, which element, that is 3, and the top is 2, right? The top is 2. As you can see that the 3 is greater than 2, and we need to maintain the greater element order in order to get our answer correct in the right direction, right? And as you can see that 3 is greater than 2, so 3 must be here, 4 3 2, then only I can say the order is maintained, right? So what I need to do, I need to pop this element out. So I will pop it, and and the stack will have the elements 4. Now I'll compare it again. So the array of I was 3 and the top is 4, so this inequality does not hold true now. So I will just again store the result. The result is again what, st dot peak, and peak is pointing to 4. So update 4 here again, and now push the current element for the next element, in order to help the next element to pre-process things. Okay, so now we have in our stack the elements as 4. Let me take a bright color. So now the stack has elements 4 and what, 3, right? Now the element came as, the current element came as 1, and the top is pointing to 3. And as you can see that the top 1 is not greater than 3, this does not hold. And you can see that the result will point to the current element st dot peak, right? Okay, so, and it will point to 3, right? So update 3 here, update 3 here, and then push the current element, that is push 1. So finally our stack will look like this thing, 4 3 and 1. But since all the elements are now processed, so we do not have to process it again. But there is a cache, there is a cache here. There is one case also that I need to explain. So what's that case? So what is that extra case that I'm talking about? So that's reside in a second test case. So let me open a paint tab again. So if we try to run the same logic on this using the stack operation, so what I can say, that the first element, what's the first element is here. So let's just write the array element. So 6 8 0 1 and 3. I will make an answer array, and for the last element I will just input -1, right? And initially my stack will have the element just 3 there, right? So now the pointer will come at 1, this one, and -2. So, so my array of I is 1, and top is saying that I am 3. So this inequality does not hold. So we'll just result is equals to top element, that is 3, right? So we will update this 3 here. Let me use a different color. We will update this 3 here, and we will push the current element, that is 1. That is 1. So the our stack will look like, it will have 3 elements, it will have 2 elements now, 3 and 1. Now the current element is pointing to what, 0 0, and the top element is pointing to 1. Again, this inequality does not hold, that the array is greater than top. This does not hold, right? So what I have to do, we can get again the answer from result is equals to st dot peak. So how I am getting this answer? Because we can see there is an element in the st dot peak that is in the right direction, which is already greater than the current element. So that's our answer, right? And that's the whole logic of maintaining the increasing order. I have already explained that thing. So ठीक है. So it will be result is equals to st dot p. So that will be 1, right? So just copy paste 1 here. For this index, 1 will be the answer, and then push the current element, that is 0. So now our stack will have what? Let me use a different color. Okay. So now the stack will have which elements? 3, 3, 1, and 0. And the current element is now pointing to 8, right? And the top is pointing to 0. Now 8 is greater than 0. We need to pop it out because as you can see, we have this current element at 8. And in the right hand direction of 8, these are all the three elements 0, 1, and 3. And that is already less than 8. So we need to pop it out, right? So we popped it out and we compared again. So 8 is the current element, and now the st dot peak is pointing to 1, this one, right? But you can see again this array of I is greater than 1, so we need to pop this out too. And I will say I'll compare it again till the elements exist, till the elements exist in the stacks. Till the element exists in the stacks means till the right elements are not over in the array, in this array, right? So I will say that 8 is greater than 3, and I will pop this out too. Now you can see the stack is empty. For the stack is empty, so stack is empty. And as you can see for this 8, if you see manually, I can say that the answer is -1, right? So there are no elements in the right direction that will make up an answer. So what I can say, if this is empty, I can write a pseudo code. In the every cases, I was just saying that result is always st.peak. Yes, but now we have to check using an inline if that what if st dot is empty. If it is empty, then means if it is yes, then that means that we don't that answer does not exist. Every right elements have been popped out and there is no answer for this particular array of I. In our case, that is 8. Or else if it is not empty, then just use the st.peak, right? So that was the catch here. Okay, so now we just have to put this current element, that is 8. So our stack will look like now the 8 is here, and the last element we need to process, that is the first element of the array, that is pointing to 6, I guess, right? Is pointing to 6, and the top is pointing to 8. As you can see, the inequality doesn't hold, that array of I greater than top, that is there is this 10 element in the right hand direction, which is we are representing using a stack. So I will say that result is equals to top element, that is equals to 8, right? And we just have to push 6. So the final stack will have the elements 8 comma 6, and since there are no elements left, so we have processed all the elements, and for this last element the answer was 8, right? As you can see. So as you can see, your output and expected output are getting matched, and the time complexity that we used here, we used O of n for stack, space complexity, and time complexity will be we just use one iteration in the stack, right? One iteration in the stack, and and at max we were visiting each element twice. At max we were visiting each element twice. That is, we were pushing it once and then we were popping it in the worst case, right? That we were popping all the elements out. So it will be O of 2n, right? So let's code the solution. So step 1 will be that we have to make a stack, and step 2 will be that we need to start from this index, right? Okay, so let's make a stack and do the code. So let's reset this editor. So let's make a long answer first of all. New long of n, and I will say that I will use an index at index is equals to n minus 1, and for the last index the answer is always -1, right? So I will say that thing, that answer of index minus minus is -1, correct? Now I have to make a stack. So it is always a good practice that not to use stack. If you have the use case of either stack or either queue, then it's a good practice that you use array deck in Java. So I don't know about C++, but it's recommended to use array deck because it is thread safe as compared to stack, and it is more efficient. Okay, so I will say that st.push the last element which I just processed. It will be array of n minus 1, right? And okay, so let's start the for loop. So it will be for int I is equals to, we are processing the second last element to the first element. So greater than equals to 0 and I minus minus, right? Okay. And till when we were popping out the elements, while this condition was holding true, that array of I is greater than st.peak, right? This condition means that there the elements in the right hand direction is less than equals to the array of I. So just remove it. We don't need that element, right? And we can do this operation only if stack is not empty. So we need to mention that operation also. So if array of I is within st.peak, so it means that there's still an element in the right hand direction which is greater than the our current I, right? So for that case, we just need to pop again and again. I already explained this case here where this was the actual case, that array of I was equals to 8 and the elements that we are getting in the stack was 0, 1 and 3. So all the elements in the right hand direction of the 8 were less than 8. So we keep on popping it, right? Okay. So, and if that's not the case, after handling this case, we used one result variable and we stored that answer. So, and I explained to you that there is one cache there, that if all the elements have been popped out using this while loop, then that means that there are no elements in the right hand direction that is greater than equals to our current processing element. In that case, we just have to return -1, or else if stack is not empty, then we have to return st.p. Now we have to store this answer. So we were using the index variable to store this answer, right? And at last, when we process that element, we have to push it in the queue, in the stack, so that the next element, that the next left element can use this uh, element, use this value. So array of I. That's it. I will say return answer. Okay. I will say return answer. And it may look like that the time complexity is getting n squared to you in the first side, but it's actually not. If you just see the dry run, that we are not doing a nested loop. We are, although we are mentioning a while loop, but if you practically look at this dry run, then what is happening at max in the worst case is that every element is getting pushed once and getting popped out once. That's the max operation we are doing for one particular element. So that will be O of 2n, right? And if I could just show you that we push 0 here, right? We, in this step, we push 0, right? And at the second step, when 8 comes, we popped out 0. So that is happening for all the elements in the worst case, right? So that will be O of 2n time complexity. So O of 2n, and the constraint here is 10 power 6. So if we do this thing, that 2 into 10 power 6 will be obviously less than 10 power 8. So if our code is right, which is, then we will not get a TLE and the code will get submitted. So let's compile and run finally, and we'll hit the submit button. Great. So let's just hit the submit button here. In the meanwhile, just let me mention the space and time complexity for you. Okay, so it got submitted, right? Okay, so we saw two approaches. One was the brute force, that was of method one, that we brutally use the nested for loop. For one such element at I, we search for the entire in the right direction using a J pointer. This was the method one, and we use O of 1. But then we did a time space trade off, and we did the time complexity of O of 2n, and we use a stack with O of n space to maintain a greater element order for every element to have to have a help. Yeah. Okay, so that is for today video. Let's meet in the tomorrow's beauty streak of day 88. And once again, yeah, if you're new to this channel, if you like my content, the way I teach you, and if it is apprehending to you, so please subscribe our channel. And few last things, that this is my DSL repository. You can start and fork to get help with the source code. And also, I have made an Instagram channel just for you guys. It's a public account. You can just connect me here, and you can ask me any doubts or any guidance if you have any, right? So ठीक है, तब तक के लिए बाय बाय, टेक केयर, कीप स्टडिंग एंड कीप लर्निंग, टेक केयर, बाय बाय.